Hello everyone, in this video we're going to go over the part 3 of the exam 2 review. This part is about identities, trigonometrical identities, and so one of the key things that we do is we want to start on one side and finish with the other side in the trigonometrical identities. In some instances, we only need to simplify some expressions like this first questions that we have here. And in some instances, we actually have whatever we're supposed to get on the other side. So let's start with this one here. So the first thing that we do with this type of things for simplifying is we're going to try to get things on the same denominator. And so one of the things we can do is essentially either simplify this or we can put this in the same denominator. So sine square is something that can be seen as 1 minus cosine square. And so I do this one here because I want to use the difference of squares. Remember, we're using the identity sine square plus cosine square equals 1. So from that, we can say, well, sine square is 1 minus cosine square, right? So that's the step that we have over here. Now, the next step that we can do is this is something that can be seen as a difference of squares. So this is 1 minus cosine of theta times 1 plus cosine of theta. Okay, and so if we do that part, we get 1 plus cos of theta, 1 minus cosine. Remember, the order doesn't matter too much. 1 plus cosine, since it's a multiplication. And so at this point, we have that this is in top and bottom. We can cancel out. And we're going to get 1 minus 1 minus cos of theta. And so notice that we distribute the minus 1 plus cos of theta. And so at the end we have cos of theta. And that's the end of the whole thing. Number 2 we can do is very similar thing, but instead of doing it with the sine, now we're doing it with the cosine. So it's exactly the same thing. Cosine square is 1 minus sine square. And so I can see that as 1 minus sine, 1 plus sine by the difference of squares. And so in the same way, this is 1 minus sine square of theta over 1 minus sine of theta, and this is 1 minus sine, 1 plus sine of theta, and then 1 minus sine of theta. We get to cancel this. We're going to get 1 minus 1 plus sine of theta. And so this 1 goes away with this, and we're going to get minus sine of theta over here. Okay? So those are simplifications. So now let's move to actually prevent some identities. So in this first one, I have 1 minus cosine of theta minus sine of theta over cosine of theta equals this. So we're going to start from this side, try to reach this one. So we always start from one side. Don't put equals to the other side, because then you will only get equalities of things that might or not might be. Now, if you have this, then you're probably going to recall that this is very similar to what we have above. We can kind of put this as 1 minus sine of theta over a single cosine of theta. And then in the next step, what we can do is we can go ahead and actually do the difference of squares. So we can do, we have the cosine here. And so we can multiply by what we're missing of the difference of squares, up and down. So it doesn't make a change. Notice this is a 1 here. But when we do this multiplication, we get 1 minus sine square. And then down below here we get cosine of theta, and we get 1 plus sine of theta. Now 1 minus sine square is cosine square. And so notice that this is going to be cosine square over cosine, and this can be seen as sine of theta plus 1. Since it's a sum, it commutes, and at the end we get cosine of theta over sine of theta plus 1, which was the other side of the identity. So notice we start from one side and then we reach the other side. That's what we want to do. So here I have something wrong with this. Okay, this is supposed to go here. Yeah, this is the identity that I just did. So let's move on to the next one, which is this one. This one is exactly the same idea that we just had. So we can pretty much go from one side to the next. So sine of theta over 1 plus cosine of theta is equals to the same thing, but we're going to multiply by what we're missing for the difference of a square. So 1 minus cos up and down. And so now this multiplication becomes 1 minus cosine square by the difference of the squares. Sine of theta, 1 minus cos of theta. And so remember, this is sine square. And we have a sine here, 1 minus cosine. We get to cancel one of the sines, and this is 1 minus cosine over sine. So as you can see, this side of the equality. And C, we pretty much do the same exercise. One thing that we can do here is realize that we can transform that 1 into sine square over sine square, so we can more easily go with the denominators. So this is sine square over, or let me just do this is step by step. This is sine square over sine square, which will be 1 plus cosine square over sine square. And then 1 minus cosine square. Notice that this is sine square here, so we can actually transform that to sine square. And we have on the top sine square plus cosine square. And you guys know that this is 1. So here's sine square, and then sine square. So this goes, and this is 1. This part's 1. So at the end, we reach the other side of the equality. All right, so moving on, let's go to E. In this case, we have cosine to the 4 minus sine to the 4. This is still a difference of the squares. We can see that as cosine square minus sine square. So this piece can be seen as this. And then separating the difference of the squares, this is cosine square of theta plus sine square of theta times cosine square of theta minus sine square of theta. So that's the difference of the squares. And I'm talking about difference of the squares, but remember that is a squared minus b squared is equals a minus b times a plus b. So I can go in this direction or I can go in this direction depending on what I need. In this case, this becomes 1. And so at the end, I just have this cosine square minus sine square. And if you remember, this is just, I can transform this cosine square here again in 1 minus sine square. And then this is going to be 1 minus 2 sine square. Okay, so we reach the other side of the identity. Now, F is an application of the double angle identities. So if you remember the formula, or you can use the formula, essentially the sine of pi plus theta is the sine of pi times the cosine of theta plus the cosine of pi times the sine of theta. Now sine of pi is 0, so this goes away. Cosine of pi is -1, so this becomes minus sine of theta, and that's where I reach the other side of the identity. Now on the next exercise, we are going to use special angles. So these are some of the angles that you should probably have memorized or have the main values of this in your unit circle. So cosine of 165 is not something that you can find out very easy, but you can see this as the cosine of the sum of two special angles. So you can have 120 and 45, right? And you should be able to then apply the formula of the cosine of double angle. This is cosine of 120 times cosine of 45 minus sine of 120 sine of 45. Now, sine of 45 is one of the main known angles that we have. This is a square root of 2 over 2. And it's the same for sine and cosine. So this is always a square root of 2 over 2. And also, the cosine of 120 is going to be -1/2. And the sine of 120 is a square root of 3 over 2. So these values come from the special angle values, and which is something that you should have in mind when you're doing this type of exercise. So now this is minus the square root of 2 over 4, and over here minus the square root of 6 over 4. And so that's pretty much going to be your answer in here. Now this is in terms of degrees, but you can pretty much have this same notion in terms of radians. So for example, sine of pi over 12, you can see this as the subtraction of, let's say, pi over 3 over minus pi over 4. So these two are two special angles in terms of radians. And this is, of course, sine of pi over 3 cosine of pi over 4, right, minus sine of pi over 3, sine of pi over 4 cosine of pi over 3. And then we're in the scenario of special angles again. Pi over 4 is the same as 45. So again, this is square root of 2 over 2, square root of 2 over 2 for this one. And sine of pi over 3 is 60. So again, this is going to be square root of 3 over 2 times the square root of 2 over 2 minus the square root of 2 over 2 times 1/2. So this is information from our special angles. And this is the square root of 6 minus the square root of 2, everything over 4. The square root of 3 times the square root of 2 is the square root of 6. The square root of 2 times 1 is square root of 2, and 2 by 2, 4. And we fold this in a single fraction. Now, 13 pi over 12, we use the same treatment. We want to break this into two different angles that we know what they are. Of course, the denominator is 12, so, well, probably we're going to have something over 3 and minus something over 4. And then here's where we have the angles that we want to find out. So from our special angles, we can play with 4 pi over 3 and pi over 4. And again, this becomes 4 by 4, 16, and minus 3, 13. So that pretty much works for creating the 13 pi over 12. Now then, this is cosine, so we apply the double angle formula for the cosine. This is cosine of 4 pi over 3 times cosine of pi over 4. minus sine of 4 pi over 3 times sine of pi over 4. And so now this is again a scenario of a special angles. This is minus 1/2 a square root of 2 over 2, and then plus minus a square root of 3 over 2 square root of 2 over 2. Okay, and then you fold this into a single fraction, and that'll be your answer. Of course, this is going to be dependent that you remember some of these special angles, so you should be able to find a special angle table that you can use and that you can memorize, or have some of the main special angles ready for memorizing or for remembering. You can pull that also from the unit circle, right? So just do your unit circle and start putting your angles in here to remember. Now the opposite scenario is when we have the law of the cosines already set up, and so you gotta fold it into a single value. So for example, this is clearly cosine times cosine minus sine times sine. So this is clearly the cosine of a sum of two angles. And so you can see this as the cosine of the sum of 24 plus 36. And so at the end, this is just cosine of 60. And that is 1/2. Same thing with this. This is sine times cosine minus sine times cosine. Notice that in the sine identity, this minus here is going to lead us to be 147 minus 27, because this minus is here. And so this is going to be sine of 120, which again is the square root of 3 over 2. Okay, so just again fold back, and just remember, you can use your special angles, and if you're not using your special angles, you can always use your calculator to find these particular values. All right, last but not least, we have these scenarios where we have information in one of the angles and information the quadrant of those angles, and then we get to find all the others. And of course, we can also use those to find out what is the double angle identities for those particular scenarios are. So alpha is going to be an angle on the second quadrant. So alpha is here, right? And so we have that the sine of alpha is 3 over 5. Okay, so if alpha belongs to the second quadrant, this is telling you that what? Cosine of alpha and sine of alpha. We have information about this. So because it's in the second quadrant, and this is as x and this is y, clearly we have that y is positive, which is true, it coincides with what we have here, 3 over 5. But we also have that the cosine is going to be negative, and it's going to be negative because it's in the second quadrant, and in the second quadrant has x being negative. So now we can calculate what is the cosine of alpha by doing 1 minus sine square alpha and getting the square root of that, right? Oh, but we just said that it was a negative value, so it's not going to be just the square root, it's just going to be minus the square root. Okay, remember this is coming from the cosine squared plus sine squared equals 1, and so when we get cosine, we get to have the plus or minus situation. So this is minus 1 minus, and then 3 over 5 the square. When you solve for this value, you're going to find out that this is 4 over 5. And so with this, you have all the information that you need about alpha. Now we do the same thing for beta. In this case, beta is going to be in the first quadrant. So beta is here. So let me erase this since I'm not going to need it. So beta belongs to quadrant 1. So this means that cosine of beta, which is x, is positive, but also that sine of beta is also positive, right? Oh, we know that the cosine is positive. We have that is 12 over 13. So cosine of beta is 12 over 13. And we have information that the sine is also positive. So in here, sine of beta is just going to be 1 minus cosine square of beta. And we get 1 minus 12 over 13 the square. And then when we find this out, we're going to find that this is 5 over 13 at the end. Okay, so this is the procedure to find the other angles that we need. So since we have the sine of alpha, we need the cosine of alpha. And since we have the cosine of beta, we need the sine of beta. And so using these identities is that we find the other angle and using the information of in what quadrant they are. First quadrant, they're both positive, x and y. Second quadrant, y is positive but x is negative. Third quadrant, they're both negative. Fourth quadrant, x is positive, y is negative. Okay? And so that's going to reflect in cosine and sine. Now, once we have this, then all these ones are going to be very easy to find. Because we just gotta play with the identities. So this is cosine of alpha, cosine of beta minus sine of alpha, sine of beta, and then with a minus that comes out from this beta here, we get a plus, and then we get to plug the values that we need. So cosine of alpha is minus 4 over 5. Cosine of beta is 12 over 13. And then plus 3 over 5, 5 over 13. Notice that we don't need to do cosine of these values. No, they already are these values. So that's what we need in here. And then you multiply all this. And at the end, this is going to give you minus 33 over 65. Then you continue to do the same things for all the others. So this cosine of alpha plus beta is pretty much same thing, but it's going to be a flip of a sign in here. And so we do the same thing, but now here we're going to have a minus in this instead of this positioning, and so that's going to give me minus 63 over 65. For the identity of the sine, then we're going to have sine of alpha cosine of beta, and because we have a minus here, then we get a minus here. Sine is b cosine of alpha. And in this scenario here, we have the plus. And then we just got to replace each of the values that are given. So 3 over 5, 12 over 13, minus 5 over 13, minus 4 over 5. So at the end, this is 56 over 65. And for this one here, we have the same thing, but there's a flip of the sign. So we have a plus here. And this is going to be 16 over 65. And that's it. This is for finding the identities. Now, notice that we have, this is asking me in which quadrant we have the alpha plus beta angle. And that we can get from finding out what the cosine of alpha plus beta is and what the sine of alpha plus beta is. So notice that cosine of alpha plus beta is a negative, and sine of alpha plus beta is positive. So this is saying x is positive and x is negative and y is positive. So where is x negative but y is positive? Quadrant 2. And that's it. This is pretty much how you go about this exercise. The last question is exactly the same in the review, so I encourage you to go through that particular question as practice, but it's doing exactly the same thing as I show you how to go in here. Make sure to check on the solutions if you need to review if your answers is okay or not okay. All right, so this is the end of the review for the exam 2.